to everyone. Myself, Dr. R.K. Biswakarma. At present, I am project coordinator of All India Coordinated Research Project on Post-Harvest Engineering and Technology, and posted at ICAR CFET Ludhiana. So, I will try to cover and give you some glimpses on the technologies for IL extraction and their relevance in small and medium IL processing enterprises. So let us see the presentation first. IL seeds, which are basically grown or cultivated in India, it comprises major edible oil seed crops that are soybean, groundnut, cottonseed, sunflower, rapeseed or mustard, sesame, safflower, and Niger seeds. These are the major edible oil seeds which are grown in India, and in different parts it is also used. These are used for the edible purposes. The second group is tree-bearing oil seeds which are edible. That is coconut, palm, olive, and sal seed. Sal seed is basically from the forest area where sal trees are grown, are there, and they collect the seeds, and specifically it is used for preparation of cocoa butter substitutes. Other sources for the edible oil are mainly comprises rice bran. After this processing, a milling of rice and polishing, this bran comes out, and it contains around 10 to 12% oil, and that is one of the edible source of edible oil source, especially in India. Also, India. Non-edible oil seeds which are grown in India are castor beans, linseed. Linseed is basically edible, but its storage life is very less. If oil is extracted, this peroxide formation and free fatty acid formation takes place within a few days. So that is why nowadays it is not used as a edible oil, but however, it is one of the most important oil seeds, and it is mainly goes to the oil paint industry for the as a base material for the paints. Then jatropha comes, jojoba, neem seed is there, karanj is there, mahua, and apricot kernel oil. This is not used for edible purposes, but it is used for some industrial or cosmetic applications. So this is the basically overview of oil seeds which are grown in India. When we see the approximate oil contents, soybean contents, I think you might have, somebody might have told you about all these things that I don't know. But soybean contains around 20%, cottonseed 23%, mustard 35%, sunflower 40%. Groundnut, it contains more than 45% oil, palm 50, and copra or coconut, it contains around 67% oil. However, groundnut is the first in the production as well as oil extraction material in India, and second comes mustard. And these two constitutes about 70% of the total oil seeds output as well as oil output in the small scale sector particularly. The technology has progressed from a primitive manual method to the mechanical methods and to the chemical methods using organic solvent, that is supercritical fluid extraction. So basically the oil extraction started from the Ghanis, and now it has come to the supercritical fluid extraction. So this is the development in the process of oil extraction. Edible oil, what is the status? We were importing around 13.13 million tons of oil in 2021. And this load is increasing continuously because our production is almost stagnant in terms of edible oil production or edible oil seeds production. So that is why our import bill is increasing. And we also import 0.4 million tons of the non-edible oils in 2021. Here there is one thing which I want to emphasize, that castor oil, we are the one of the major exporters of the castor oil, which is used for the as a base material for the production of grease or these lubricating oils. So most of the petroleum industry companies, they import castor oil from India. And one diversion has taken place. Edible oils are now used as for the production of biodiesel, in particularly in the developed world, and that is why this our edible oil source is decreasing continuously because it is going for the industrial uses. In India, we produce around 1.2 million tons of Banaspati ghee, which is basically hydrogenation of edible oils or some non-edible oils after refining, and then it looks like ghee of white color. So it has a 10% share in the edible oil industry. So this is the status of edible and non-edible oils, and scope also. How can we increase, or what are the possible export potentials of the edible or non-edible oils? Characteristics, if we see that it covers a large geographical area, but the first issue comes seasonality of the oil seeds, because all except tree-borne oil seeds also, they come in a particular season, except coconut. For example, mustard comes in the comes as a rabi crop, whereas a groundnut comes as a kharif crop. So these are the things which are there. Regional diversity of oil seeds and oil, basically in India, in different parts, whatever locally grown oil seeds are there, that oil extracted from that is used by the people of that region. For example, if we see the mustard oil, mustard seed is grown in northern part of India, so it is very popular in northern part. But in Gujarat, they cultivate groundnut, so that is why groundnut oil is used in most of the preparations. In southern India, coconut is the one of the major source of oil. So most of the cooking or this application as edible purpose, this coconut oil is used. Then consumer preference for the raw expeller oils. This is one of the aspects which is coming up, and we can say being popularized as a, we can say that low temperature extraction, or we can say this somebody also called it organic expelling. So, but it is not so. I will tell you what are the major differences. And we are the largest importer of edible oils in the world. The issue first which comes in our country is oil seed processing industries are at low capacity utilization. only 30 to 38% capacity, total capacity is utilized in a year. So this is one of the problems. And this expellers, particularly if we talk, we are installing everywhere. So this capacity utilization is coming down. And oil mills and solvent extraction units, if you go through this all installations, now some changes has taken place, but most of them are outdated and they need renovation or modernization. Low oil recoveries and high unit cost and lack of integration between our expelling and solvent extraction units. This is one of the major aspect I will tell you later. Post-harvest losses, if we see in the oil seeds, it was ranging in particularly farm operations 3.1% to 10%, and the storage losses for different oil seeds range from 0.2 to 1.61%. So basically, this was a study conducted by CFET in 2013-14. So that data is there. You can see that the total losses in farm operations, mustard is highest. Soybean has highest losses, particularly when this harvesting is done in the month of April, and at that time, very high temperature is there. So during harvesting, shattering losses takes place to a very good extent. Around 5.5% seeds are shattered because as the temperature increases during harvesting, the pods break themselves. So the total losses which are there, overall total losses. So we are losing around 3.1% to 10% in the oilseed crops. Crushing units, different kind of, we evaluate oil processing industries, either at a small scale or at a large scale. So this is the scenario. So oilseed crushing units, or we can say expellers, they are around 1,50,000 and can cover 4.25 million tons, and its average capacity utilization is only 10%. Solvent extraction units, there are 766, and their capacity is 3.6 million tons, and their capacity utilization is somewhat better than our expeller units. In case of cotton seed, capacity utilization of crushing unit is only 3% of the installed capacity, because this cotton seed oil cannot be used directly for the cooking. First, it has to go for the physical refining, and then only it can be used as a edible for edible purpose. So that is why these crushing units, which are using cotton seed, has a very less capacity utilization. Sorry. Unit operations which are involved in the oil seed processing. So first comes grading of the oil seeds. Second comes decortication. In some of the cases, in some of the cases, it is not required. For example, in groundnut, decortication is must. In case of mustard, no decortication is required. In case of sunflower, uh, somewhere decortication is done, and in some industries, without decortication, it is extracted. Instant addition of moisture in some of the cases, particularly when we talk about expelling units. So instant addition of moisture is done, because when we go for the oil extraction through mechanical expellers, the moisture content should be less than 10%. And instant addition of moisture just does not increase basically the seed moisture content, but it helps in reducing the temperature as well as it works as a lubricant. So this is the purpose. If we are adding and increasing the moisture content beyond 10% of the seed, then expelling will be very difficult. In some cases, it will not expel. In some of the cases, moisture addition 24 hours prior to the expression is also done. Size reduction is one of the aspects, and steaming, particularly in some of the IL seeds, steam is given in place of adding water, and then expelling is done. So these are the primary unit operations which are involved in the IL seeds processing. Traditional method of oil seeds processing in India, this is the one crushing system developed in the form of a mortar pestle type of arrangement. And this is basically called Ghani or Kolu in India. And I will show you the picture. If we see in the beginning of 1900 or 1910, we have around 5 lakh bullock cart-driven Ghanis, and they were crushing almost 95% of the total oil seeds. At that time, the production was only 8 lakh tons, and only 4% of the all oil seeds are pressed in the Ghanis. And especially these Ghanis are used particularly in the for the oil expelling of mustard. So this is the Ghani and its mechanical version, in which pressing unit, we can say a very big mortar is there that is made of wood, and a pestle is placed, and a bullock rotates the pestle and mortar, and then the slurry is formed, and from slurry oil starts oozing out. So this was the process uh, in the start of 1900, or we can in the start of 20th century. Now we have moved towards complete mechanization, and this kind of system is very less in use. So you have seen that picture, and you can get a very clear view whatever is written here. These are the power Ghanis which are being used at present, and if I say that Coimbatore is the hub of uh, manufacturing power Ghanis, as well as in the recent 2 3 years, those cold presses in which this part, this mortar part, is made of wood, and we can say that is the replica of Kolu, which was used in the past uh, and powered by the bullocks. So the same system, almost there is no difference. In place of this cast iron, they are using uh, mortar of wood, and they are saying that this oil is very good, and this has happened, that has happened. But the issue is in power khanis or in coals which are made of wood, around 15 to 20% oil is always left in the cake. So the only the seeds which have more than 20% oil, that can only be crushed into the power khanis, or as well as coals of wood or anything. So energy requirement is higher than the expellers, and much higher than that of solvent extraction. So these are the two lacunas, particularly if we talk about the oil extraction process of Ghanis. And uh, these Ghanis are specifically used in the uh, mustard growing areas, particularly if I talk about Rajasthan. They expel the oil first using these power Ghanis. Then the cake which has around 20% oil, that goes for oil expelling through the expellers. And finally, the cake, mustard cake is basically sold as an animal feed. So they call it kachi ghani oil, mustard oil, kachi ghani mustard oil. So this is the kachi ghani mustard oil, nothing else. But these are not efficient machines. Capacity is very less. In case of wooden garnish, only 10 kg can be crushed at a time. Pressures development is there. Life is 4 to 5 years. And after that, this wood has to be replaced. So they expel around 5% less oil, because in case of expellers, around 9 to 10% oil is left in the cake, but in case of garnish, it is more than 15%. And ghani cake is entirely different from the cake which comes from the expeller. So this is one of the case also, where if we are not processing the oil cake using oil, this oil cake coming from the ghanies to oil expellers, then that cake will it will be very difficult to directly give as an animal feed. First, we have to crush it, and that requires high energy, because this cake is very hard. So this is the issue of particularly in case of garnish. Flavor, yes, flavor is retained. Particularly volatile flavors are mainly retained in the uh, 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 garnish or kolos. So that is why people think that this oil which is taken out by the garnish is better than all other oils which are extracted through mechanical expellers or through solvent extraction. Second technology, which is uh, popular and most popular in India, is the screw press, or we can say the mechanical oil expellers. So this was also developed in early 90s, and it is highly prevalent in India, and in developed countries. They are using these screw presses or oil expellers for the extraction of oil at their farms, because their farm size is very big. So they extract, suppose in Sweden or Spain, they uh, take very high capacities, for example, 10 tons or 20 tons per hour capacity oil expellers. They expel the oil using these expellers, and they convert it, the oil into uh, biodiesel, and their all farm operations are run through that oil. So they are not using for the edible oil purposes, but they are using as a source of energy for their farms. And surprisingly, we are the leader in manufacturing of screw press or oil expellers, and we are the major exporters throughout the world. Even developed countries also, they purchase the expellers from India. Basically, it is a flighted screw which is rotating within a slotted barrel, and barrel is of fixed diameter. Root diameter of the screw increases, particularly at the feeding end it is more, and when it comes to the discharge end it is reduced, so that pressure can be generated to take out the oil. And this is basically not developed through any research, we can say. This oil expeller, which are used at present, are through trials and errors. So this is the basically we can say the total oil expeller technology, or anything which we talk about. There is always a feeding mechanism. This feed may be heated or steamed also. So in some of the expellers, you will find a device at the top of the hopper or feeder where the steam, raw material comes and steaming is done, and that hot steamed material with higher moisture is fed to the expeller. So the first part is your feeding system, second part is crushing, and third part is the pressing. And this pressure can be increased using the screw shaft or decreased uh, depending upon the oil seed. Here, the most important thing is in case of oil expellers, here we are bound to leave some fibrous material with the oil seeds. For example, if we crush the groundnut or peanuts in the oil expellers, so we have to decorticate the this groundnut, but at least around 10% groundnut should be with the husk. Then remaining 90% or from 90%, this husk is or cell is removed, and then it is fed to the oil expellers. So this is a story, and if somewhere if you want or somebody wants that he should get the oil cake without any husk or without any fibrous material, then they have to uh, add some material which is fibrous and which can generate some friction between screw and oil seed. So increase to increase the friction, any edible material has to be added into the oil seeds. Then only we can expel the oil through the oil expellers. So this is one of the issue if we want the oil cake free from the husk. So this is one of the manufacturer is there in Ludhiana. So they manufacture this kind of oil seeds. Uh, they are manufacturing these oil seed expellers from 7.5 horsepower to 75 horsepower. It means 75 horsepower means its capacity is around 10 tons per hour. So depending upon the screw length, everything changes, capacity changes, and the diameter of the screw is also changed. So in general, you will find these are the bolts which are placed, and these bolts hold the cage. So commonly you will find this is 6-bolt expeller or 8-bolt expeller or 12-bolt expeller. So these bolts are counted, but basically it is the increasing the size of the screw and diameter of the screw to increase the capacity. One uh, since last 2-3 years, small capacity oil expellers has also been introduced in different parts of the India, and their capacity is very less. Only 12 to 13 kg feed can be given in these oil expellers. Basically, these we can say these are the miniature version of oil expellers. Their screw size is very less, screw length is very less, so that is why sufficient pressure does not develop. So they have changed the process in which they heat the screw to around 250 degrees Celsius, and feed is also heated, and then it is fed to the expeller. So, and moisture content should be very less, around 4% moisture content should be there. So we tested this machine on coconut and peanut, and there is no adjustment in this. Power consumption is very high, 1.37 kilowatt per hour, and oil recovery in one pass is very good. 50% in the coconut, when it contains around 55% oil, and 40% in the peanut. Only 5% residual oil is there. This is because of expelling at very high temperature. So these are very good, particularly if we want, or if at household level we think that we should use pure oil expelled at our in front of my eyes or our eyes, or in our kitchen. So these kind of instruments are very good. Cost is not more, around 30 to 35,000 only. So these are good for. These are the oil expellers, miniature oil expellers. Somebody asked. Miniature oil expellers. These are very commonly manufactured in India now. Its cost is around 35,000, 30 to 35,000. The only issue which will come is the oil temperature will rise to around 100 degrees Celsius in this case. And after expelling, you have to store the oil in a closed container without any air, if you want to use within 1 month. Even then, you have to pack it in an airtight container. The continuous screw press have been used in two ways for the oil seed extraction, after heat conditioning and pressing in multiple times. So actually, when we talk about micro and small capacity units where oil expellers are used, in micro they have only one expeller. So once oil seed is fed, and around 72% of the total oil is recovered in the first pass, then oil cake is fed to the machine again. So this process is done at least 3 to 4 times. Then we can get 5 to 6% of the residual oil in the cake. If you try to extract the remaining oil and again feed into the machine, then burning of the cake may take place. So that is why 3 to 4 passes, particularly for the most of the oil seeds, are preferred. At a micro level, screw presses or mechanical expellers. In some of the other cases, there are different kind of system is going on in India. Particularly if we talk about Rajasthan for this mustard oil extraction, they use battery of expellers. In first expeller, they will feed the oil seed, and cake is fed to the second machine. From the second machine, whatever cake is coming, that is fed to the third screw press. So this battery of expellers, 3 to 4 expellers are there in the line, and from one end they feed the oil seed, from other end they get the oil cake, having 5 to 7% or 8% residual oil. In second case, particularly this is followed for sunflower and safflower oil extraction. They use, and even if solvent extraction unit is also there, they will use screw presses or mechanical expellers to extract around 70% oil in a single pass. 70% oil present in the seed. So that is used for those oil seeds where oil content is more than 30%. So they pass it through the mechanical expeller and extract around 70% of the total oil. Then that cake is either used by the solvent extraction unit, or the small entrepreneurs, they sell the cake to the solvent extraction units, and their rate is decided on the residual oil in the cake. So they measure it, and accordingly they pay to the small entrepreneurs for their cake, and they use the cake for the solvent extraction. So these are the two systems which are very common in India, particularly when we talk about the mechanical expelling and screw pressing. So if anybody is interested for the screw press or at a small level, he or she has to think about uh, the sale of oil cake to the solvent extraction units. Then they can get a better price of their cake in the market. After that, the second aspect comes when oil is extracted. Filter press is there, or press, we can say filtering of the oil is done. This is the second step, which should be present in any oil extraction unit. Basically, when we use this mechanical expellers, so along with oil, some cake particles also come along with that oil. So if we have to store it, because oil has to be stored, then it is mandatory to remove those oil cake particles from the oil, so that they does not impair the quality of the oil during the storage. So there are several filters, and this is very common filter, which is available since 1950s or 1940s, and it is still common in the industry, in which between the plates, you can see the plates in this, and in between the plates, one cloth, uh, this canvas kind of cloth is placed, and oil is pumped through a positive displacement pump to the this filter press, and oil passes through it, whereas the cake particles are deposited on the surface of the cloth, and we get clean filtered oil. So if you see that single filtered or double filtered, it means from this cloth filter they have passed one in single filter, or double filter means they have passed uh, after first filter press, they have passed to the second filter press. So most of the oil cake particles are removed, and quality of the oil better for particularly for the storage. So the new technologies which are emerging are twin screw mechanical expelling, uh, extrusion expelling. In case of solvent extraction unit, use of less hazardous solvents in place of hexane. Then supercritical fluid extraction. Then some new pre-treatments have come for better oil recovery, that is enzymatic hydrolysis, extrusion cooking, ultrasound assistance, and microwave heating. So these are the pre-treatments, and these are the new technologies which are coming up. Use of less hazardous solvents in place of hexane. I am giving you one example. The solvent extraction units, what happens? Uh, these wherever these solvents, solventizing unit and desolventing unit is placed in the industry. So the workers which they work there, they are retired after 15 years of work, and the companies pay a handsome amount to them, and after that whatever happens to the worker, they don't bother. So the reason is hexane has an accumulative effect. If we inhale the hexane vapors continuously, our body does not recognize it as a foreign matter. So it is accumulated through our this respiration. So it is accumulated in the body, and once it reaches to a threshold limit, it shows its character, and different kind of disease, particularly cancer takes place to the workers. So that is why after 15 years they retire. So less hazardous solvents are still in search, and some of the industries have changed. They have come to the ether and some other kind of solvents also. Solvent extraction. This is the most widely used method to extract oil, particularly in the developed world. In the developed world, they don't use mechanical expellers or coals or garnets for the oil extraction, particularly when we talk about the edible oil. So here also cleaning, drying, tempering, cracking, dehelling, conditioning, and final operation is flaking, because we basically spray the solvents on the oil seeds. So in the form of flakes, surface area is increased, and then oil extraction becomes easy. So this in additional primary operation comes flaking. De-oil cake, then size reduction is done. Solvent, which is very common, is the normal hexane. This is a petroleum distillate, and residual oil in the meal is less than 1% at present. Earlier it was 1 to 2%, but at present it is less than 1%. But here comes any solvent extraction unit of less than 100 tons per day capacity is not economically viable. Our small scale units like mechanical expellers, we can keep 50 or 100 mechanical expellers, or 5 or 6 high capacity mechanical expellers, or we can keep a battery of garnets. So to increase the capacity, but they are economically viable at a smaller capacity also. Any entrepreneur is using these mechanical expellers, so he can survive on that expeller if he is crushing more than 200 kg of oil seeds daily. But in case of solvent extraction units, minimum capacity should be 100 tons per day. Otherwise, it is not economically viable. And if we see the history, first solvent extraction plant was established in 1945 at Bhavnagar in Gujarat, and that was for the extraction of oil from the residue, this oil cake of groundnut. Second is use of extruder for oil seed processing. Expanders basically are used, and it has unsegmented barrel housing and a warm screw with interrupted flights, and it converts flaked oil seeds into porous but is much denser collet so as to allow more material. So basically, expanders are used, particularly these extruders. When if you see the extruders, what it does, uh, material passes at a very high pressure, and suddenly it comes out at a normal pressure. So pressure drop takes place, and material expansion takes place. Basically, starch expansion takes place. So porous structure is formed, and that porous material is fed to the either mechanical expeller or the solvent extraction unit. The extraction rate is increased drastically, so that is why time of extraction is reduced. So at one place, this kind of system reduces the solvent use as well as increases the plant capacity. So that is why expanders are very commonly used in the solvent extraction. Extruding expelling system, basically this was tried, but still not very common. Oil seeds like soya bean are first crushed, and then extruded at 100, around more than 100 degrees Celsius. And from that, oil comes out. So this is specifically used in case of those oil seeds where oil content is less than 20%. But it is not common. Aqueous extraction process or a hot water flotation method. This is very particularly this is used for the olive oil extraction, and it is very recent kind of thing where this aqueous extraction process or hot water flotation method is being used. Oil extraction yield is very good, but we have to take care after taking out oil, so to reduce or remove the moisture from the oil. That is the most important factor in aqueous oil extraction process. These are common for olive oil, and for other oil seeds, this can also be. Enzyme added, in this case, enzymes are, for example, alpha amylase or pectinase. These are the enzymes. Basically, they act on the cellular wall and they reduce the strength of cellular walls or break the walls so that oil extraction becomes easy. So enzymes are basically used as a catalyst in these cases to increase or enhance the oil expelling rate. Supercritical fluid extraction. This is a very costly technology. It is being used in India at some locations. High capacity supercritical fluid extraction units are installed. Its capital investment is very high. You can say if we want to install one such kind of system, we have to invest at least 50 crores for this purpose. But its oil quality, 100%, almost 100% oil extraction, and quality of oil is phenomenal in comparison to the solvent extraction or mechanical expellers. But because in this case, supercritical fluids, particularly carbon dioxide or nitrogen, not nitrogen, carbon dioxide kind of gases are used. So basically, when any gas temperature is reduced and pressure is increased, so that it can be in the below the this critical, there is a critical stage. So it becomes almost liquid, converts into the almost liquid form, and that liquid acts as a solvent like hexane. And the oil is dissolved in that, and once we take it out, so because it is exposed to the normal environmental conditions, carbon dioxide converts into the gas form, and almost all carbon dioxide goes out from the oil. So that is why oil quality as well as cabin quality is phenomenal in supercritical environments. But here the cost factor is there, and that is why it is used for high value oils for the extraction of oil from such kind of materials. The advantages: higher diffusivity is there, lower viscosity of the oil will come, adjustable density, we can manipulate it. Supercritical fluid extraction can be manipulated to, or we can say not manipulation, we can say set the parameters to get a different kind of oil, and it is totally free from the solvent residues. And it is best suited for the essential oils and oleoresins and other high value products, particularly for the pharmaceutical and cosmetic industry. Uh, but capacity is less and cost is very high. Microwave application, uh, this is at the laboratory stage, I will say. We know that microwave ovens particularly are very common at the household level, and particularly we use it for heating the food products. So, but for the use in the industry, particularly oil industry, uh, basically this is an assistance, we can say, a pre-treatment process uh, for the oil seed. It does not take out the oil from the oil seeds. So what happens, because it's a very fast heating takes place. So once we keep any this oil seed material into the microwave oven, it heats it within 30 seconds or 60 seconds, and cell walls are ruptured. And when it is after this, it is fed to the mechanical expeller or solvent extraction, oil extraction efficiency, as well as uh, rate of the oil extraction increased drastically. So that is why this is the application, and we can say it's a microwave. Microwave is a pre-treatment process for getting better oil recovery at lower energy in the oil seed industries. But continuous kind of microwaves for oil, such kind of heating are not commonly available, and these are, we can say, the continuous microwave systems are in the development stage. In future, this technology will certainly be used as a pre-treatment for the oil extraction. I show you that uh, filter press, but now this is becoming popular, particularly for the filtering of the oil, that is centrifugal oil filtering machine. So basically, this is, uh, we can say, it acts on the principle of centrifugal force, and we rotate the oil at a very high speed, and there is a screen is there, so oil comes out and cake remains inside the this chamber. The uh, most good part of this kind of centrifugal oil filter machine is, for example, take mahua oil. When it is extracted, oil is extracted through mechanical expellers, you will find uh, a good quantity of this oil cake particles in that oil, extracted oil. So if you will keep it for half 2 3 hours, that cake will deposit, and it forms a grease kind of, or we can say viscous, very viscous material. So in filter press, you can cloth filter press, you cannot filter it, because after feeding only 10 to 15 liters of the mahua oil, that cloths are choked. So this kind of system are very good for uh, removal of those oil cake particles wherever uh, high quantity of oil cakes are coming along with the oil. So these machines are introduced and very good, particularly for this uh, mechanical expelling units. Refining, the first refining or we stage is, sorry, as I told you, is the filtering and the removal of the oil cake particles from the oil. But some of the oils cannot be used directly for food purposes. For example, cottonseed oil or mahua oil or some other oils are also there. they cannot be used directly for the cooking or for food purposes. So mustard oil, coconut, groundnut, soya bean, sunflower, these are very common, they can be used, but mahua oil or cottonseed oil cannot be used. So they have to go through a refining process, and in that, there are different steps in that. First is degumming. Some gums are always present in the oil, so gums are removed. In this case, the oil is basically cooled down to a very lower temperature, or we can say less than 0 degrees Celsius. So gums are converted into the solid phase, and after filtering, that gum is removed. Then whatever oil comes, then it is goes for alkali refining. Alkali refining is nothing but we can say the removal of free fatty acid which have been formed during the storage or during extraction process. So alkali refining means we add sodium hydroxide in that, and that sodium hydroxide reacts with free fatty acids at higher temperature. So oil is heated first, and then uh, glycerol and soap is formed. So these are the two byproducts, particularly of the refining industry. Uh, we get this glycerin and then soap as a byproduct. After that, when free fatty acid is reduced, and there is one limit. If the oil contains more than 10% of the free fatty acid, that is not good for the refining and not good for the food consumption also. So refining is done only when the free fatty acid is less than 10%. After that, neutralization process comes, and in this, because we have added sodium hydroxide, if remaining is there, then we have to neutralize it. Then comes bleaching. Bleaching is basically removal of color particles from the oils. So in this case, uh, one kind of earth, this uh, dust is used, that is called diatomaceous earth or activated earth, and it is also used in the petroleum refining industries for the bleaching. So that is mixed with the oil at a higher temperature, and then filtering is done. So almost most of the color components or pigments are removed from the oil, and then we get uh, low color value oil with almost we can say free from gums, then free fatty acids, and then color components. In case of hydrogenation, these refined oil, this is the refining step ends here, and then these oil are used for the hydrogenation, vanaspati ghee production. Then hydrogenation process starts, and finally, after that, this deodorization of the oil is done. For our health benefits, what we should eat and what we should recommend to the consumers if we are an entrepreneur, we are extracting the oil. So these are the combination: groundnut mustard, groundnut canola, groundnut soybean. The purpose of this slide is only one thing. For a good health, never eat one oil continuously or regularly. You can change the oil. If you are using 10 days mustard oil, then you should eat 10 days groundnut oil, then some other oil also, like coconut oil. So all edible oils which are present, and those are extracted particularly through mechanical expellers or ghanis, or even solvent extraction if residual solvent is not there. So those ILs should be used and not continuously one IL. We have to change them for our good health. After that, whenever we talk about any enterprise uh, and we calculate the profitability, so the profitability only comes from the byproducts. Uh, for example, in pulse milling industry, the profit margin is the only uh, husk as well as the broken and powder generation, whatever they sell it to the feed industries. So that is their profit margin. Otherwise, whatever dal is produced, that recovers their cost of the raw material as well as the operational cost. So they are, we can say, at the break even when they are using the main product. Similar is the case of oil seeds also. If we are expelling oil, so byproduct, whatever cake is coming, that is our, we can say, the profit margin. So here, these industries has to focus on how can they get the better byproducts so that they can get better price in the market to increase their profitability. So different uses are there. Uh, for example, this peanut or groundnut. If we are extracting oil along with the husk, the oil cake will not remain as a edible product. But if after removing the husk, if we are extracting the oil cake will fetch a better price. So accordingly, we have to think about whatever raw material we are using and which kind of byproduct we are getting. In mechanical expellers, burning is the issue. So you have to think how many passes you have to give, 2 or 3 or more than 3. Depending upon that, you have to decide and then accordingly you have to work. Because your profitability will come from the here only. And some of the industries, for example, in fortification, industries can take your byproduct. In in case of soybean, milk and tofu industries can take, or soy nuts, or this soy buddies. Manufacturing units can take your products. In bakery, also used in noodles. Uh, Sunflower kernel is that is a separate thing, and mustard or sunflower meal for edible purposes. Then another industry which was not in common in India, now a few industries has come, that is protein concentrate or protein isolates manufacturing units. Uh, Remember that all the IL seeds are also rich in protein. Either we talk about mustard or we talk about coconut or groundnut, they are very rich in protein. So once IL cake comes, so if it is sold to those units who are extracting protein isolates or protein concentrate from these byproducts, they can give you a better price than normal feeding industries. There is another area if you are interested in supercritical fluid extraction or distillation process or uh, this solvent extraction process. So essential oils and oleoresins, I kept this particular slide because in Tamil Nadu, Kerala and Karnataka, uh, these spice and aromatic extracts are very common. Uh, and they are the major growers and world exporters of these essential oils and oleoresins. So some of the units of these kind of essential oils and oleoresin extraction units have been established in that part, and uh, that can be an avenue for small entrepreneurs to supply raw material or doing some business with such kind of industries. So basically, this is a different kind of process. It can be used in several industries. Finally, this is the slide. What we eat and what are the good for health. These are the superfoods called superfoods for the health and happiness. Soybean, isabgol, garlic, fenugreek, bengal gram, and avla. So these all super six things. Uh, uh, Forget about soybean. Our oil seeds are there. For example, coconut or groundnut. These are linseed. These are very good for health. So these comes as a super six foods for our good health and happiness and good uh, well-being. So thank you very much because I have to stop here uh, because at 3:30 I have to join another meeting immediately. So thank you very much for a patient hearing.
Participants, if you have any questions, you can quickly ask, sir, because I have to go for a meeting. If any question is there, we can take up right now.
Good afternoon, Vishwakarma ji.
Yeah, good afternoon. ma'am.
मुझे that machine you were showing, centrifugal oil expeller
Yeah.
for Mahua and all. Is it? Can you give us the list of manufacturers of the equipments you showed us?
Yes,
So
yes.
contact details. That would be really.
Yeah, only I could identify only two. And
Okay.
this is my recent, we can say, exploration.
Okay.
When I was working for the Chhattisgarh Forest Department. So there I identified this problem. So they were filtering it by heating the oil and then
Yeah.
filtering it.
Yeah, we are
So,
also doing for kokum butter, same way. So it could be useful for us too. So I was just
Sure.
thinking of exploring that.
I will give you the address.
Yeah, thank you so much.
Thank you. I have your phone number. I will.
Yeah, please, you share.
Thank you, sir.
Good afternoon, sir.
Yeah, good afternoon.
During your first part of lecture, you were telling about oil cake free from husk. You were showing the example of groundnut. So I couldn't understand that part, sir.
In fact, what happens in mechanical expelling, you can do the expelling by two means. You can feed the groundnut along with husk to the expeller. But what will happen, this husk or we can say shell of the groundnut is not edible. So you will get oil, but your oil cake will be of no use.
Okay, sir.
But in the industry, what they do, if it is a small entrepreneur, they dehusk or we can say deshell the groundnut first. In that case, 90% of the husk is removed. Only 10% of the groundnut husk is there. That husk is required for the development of friction, or we can say abrasion and friction during the expelling process. If we will remove that, then oil expelling will not take place. So in most of the cases, they remove 90% of the hull, 90 hull from the 90% of the material, and in 10% hull is there. Then it is fed to the mechanical expellers. If you want to get pure, we can say oil cake free from husk, then you have to go for 100% decortication. Then you have to add some edible fibrous material in the oil seed, or we can say the groundnut, and then mechanical expelling can be done. So, for example, wheat bran can be added, or the oil cake of this groundnut after passing it through the 3-4 times, then that the oil cake also acts as a friction enhancer. So that can be added, then you will get the oil from the oil extractors.
Okay, sir. Thank you.